Imagine we had the fraction 1 over the square root of 3. The number on the top here, the 1, is the numerator, and on the bottom we have square root 3, which is the denominator. For this video, we're interested in the denominator. You might remember from a previous video that surds are examples of irrational numbers. So at the moment, the denominator here is irrational. You can tell from the title of this video that we want it to be rational. So in order to rationalize a denominator, we'll need to remove the surd from the bottom of the fraction. And this is how we do it. We're going to multiply this fraction by another fraction. We're going to make the denominator of this new fraction the same as the denominator from that original fraction, so square root 3. The reason we make this choice is because when you multiply square root 3 by itself, you get 3, which is now rational. So the next question is, well, what do we multiply on the numerator? Well, it's actually just square root 3 again. The reason for this is if you do square root 3 divided by square root 3, you get 1. So if we multiply this fraction by something that's the same as 1, then it remains unchanged, since 1 times by any number is still the same number. So the result we get from multiplying these fractions together must be the same as the original fraction, 1 over square root 3. But it's just going to be in a different form where the bottom is rational. So if we now multiply these fractions together, we'll do 1 times square root 3 on the top, that's square root 3, and on the bottom, root 3 times root 3 is 3. Notice how the denominator is now a rational number. So we could say that 1 over square root 3 is the same as square root 3 over 3, and we have now rationalized the denominator. Let's try another example. So let's try 1 over square root 7. So we're going to multiply this on the bottom by square root 7 and on the top by square root 7. On the top we do 1 times square root 7, that's square root 7, and on the bottom, square root 7 multiplied by itself is 7. So 1 over root 7 is the same as root 7 over 7. Let's try another. So this time we've got a 5 on the top, not a 1 anymore. Since there's a square root 2 on the bottom, we're going to multiply by square root 2 over square root 2. 5 times square root 2 is 5 root 2, and on the bottom, square root 2 times by itself is 2. Sometimes when you've rationalized the denominator, you need to do some further simplifying. Let's try one like that. So this time we have 30 over root 5. We're going to multiply by root 5 over root 5. On the top, 30 times root 5 is 30 root 5, and on the bottom, root 5 times root 5 is 5. Now this one can simplify further. If we look at 30 over 5, that's the same as 30 divided by 5, which is 6. So the answer to this question, fully simplified, would be 6 lots of root 5, or 6 root 5. Let's try another one. So for this one, we're going to do 4 over root 10. So we multiply by root 10 over root 10. On the top, 4 lots of root 10 is 4 root 10, and on the bottom, root 10 times by itself is 10. Now we can look at the 4 over 10 here to simplify, but 4 divided by 10 doesn't give you a nice integer answer this time. However, if you imagine it as a fraction 4 over 10 and simplify, 4 over 10 is the same as 2 over 5. So if we write this again, but replace the 4 with a 2 and the 10 with a 5, and then root 10. So this is 2 root 10 over 5. Now let's look at some more complicated examples. So this one here, 5 over 4 root 6. This one's a little bit more complicated because it has this number 4 here. You may think for this one that we need to multiply by 4 root 6 over 4 root 6. But actually we don't. We just need to multiply by root 6 over root 6. and that will still get rid of the surd on the bottom. So on the top, we do 5 times root 6, which is 5 root 6. Then on the bottom, multiplying root 6 by root 6 will give us 6, but we also have this 4 here, so on the bottom we've got 4 times 6. So if we keep the top as 5 root 6, and on the bottom 4 times 6 is 24. At this point we check these two numbers to see if we can simplify, and this one we actually can't, since there's no common factors apart from 1, so we'll leave it as 5 root 6 over 24. Let's try another one. Now this one doesn't have that number at the front, and you may be thinking of multiplying by root 50 over root 50, which will be fine and you can get to the answer, but it's probably easier to simplify root 50 first. Root 50 could be expressed as root 25 times root 2. Root 25 is 5, so this is the same as 5 root 2. So before we rationalise this one, I've simplified the root 50 into 5 root 2. Then we can multiply by root 2 over root 2. 11 times root 2 on the top is 11 root 2. And on the bottom, I do root 2 times by root 2, which is 2. But there's also this 5 here, so 5 times 2. On the top, I have 11 root 2. And on the bottom, 5 times 2, which is 10. Check the 11 and the 10 here to see if you can simplify, and on this one you can't, so it's 11 root 2 over 10. Now that you've become familiar with how to rationalise the denominator, let's have a look at how it could be used in an exam question. So we've got the question, write root 28 plus 35 over root 7 in the form a root b, and we need to give the values of a and b once we've found them. At the moment we can't add these two things together because they don't have the same number inside the root, so we're going to need to do some simplifying first. Let's take square root 28 and rewrite that as root 4 times root 7. Root 4 is just 2, so it's 2 times root 7, which is 2 root 7. So that's the root 28 simplified, but what about 35 over square root 7? Well, we can rationalise the denominator here. Let's multiply by root 7 over root 7. On the top, 35 times root 7, that's 35 root 7, and on the bottom, root 7 times by itself is 7. This one can simplify, we've got 35 over 7, and 35 does divide by 7 nicely, that gives you 5. So this is just 5 root 7. So we've changed the root 28 into 2 root 7, and the 35 over root 7 into 5 root 7, we just need to add them together. So 2 root 7 plus 5 root 7, you do 2 plus 5 to get 7 root 7. This question asked us to give the values of a and b, so a is the number in front of the root, that's 7, and b is the number inside the root, which is also 7. Sometimes we have a fraction where there's more than one term on the top, like this one here. Let's begin this one by simplifying the root 44 on the bottom. Root 44 is the same as root 4 times root 11, and the root of 4 is 2, so we've got 2 times root 11, which is 2 root 11. So if we replace the root 44 with 2 root 11. Now we can multiply by root 11 over root 11. On the top, this is a little bit different to the previous examples. We need to multiply square root 6 minus 3 by root 11. But there are two terms there, root 6 and negative 3. So we're going to put those in a bracket. And in fact, it's probably easier to write the root 11 first. So this is root 11 multiplied by a bracket containing root 6 minus 3. On the bottom we do as we did before, root 11 multiplied by itself is 11, and we've also got this times 2, so 2 lots of 11 are 22. Now we can expand the brackets on the top. I've made a whole video on how to expand brackets with surd, so if you haven't watched that yet, you may want to watch that before watching the remainder of this video, because there's going to be quite a few brackets. So what we do is we do root 11 times root 6, which is root 66, and then root 11 times negative 3, which is negative 3 root 11. And then on the bottom we have 22. There's no further simplifying we can do here, so we just leave this one as the answer. Now if your exam board for maths is Edexcel or OCR, then you're going to need to watch the rest of this video. But if you do AQA, the remaining content in this video isn't assessed on your course. It is however assessed in the Level 2 Further Maths course, and if you're going to do maths at A level, you'll definitely need to know this anyway, so it's up to you whether you continue. We're now going to look at examples where the denominator contains two terms, like this one here, 3 subtract root 5. Your first instinct here is to probably multiply by root 5 over root 5. Let's see what happens. Well, on the top we do 6 times root 5, which is 6 root 5, and on the bottom we need to use a bracket, so we've got root 5 times 3 subtract root 5. So let's leave the 6 root 5 on the top and expand that bracket on the bottom. We've got root 5 times 3, which is 3 root 5, and root 5 times negative root 5, which is negative 5. So we end up with this. Now unfortunately we still have a root 5 on the bottom, which means our denominator is not rational, it's irrational. And this is not what we were trying to do. So something went wrong in our method. When you have a fraction like this with two terms on the bottom and at least one of them is a surd, we need a different approach. We're still going to multiply them by a fraction, but what we're going to do is multiply by the exact same denominator apart from change the sign in between the two terms. So here we have 3 minus root 5. We're going to change this minus into a positive, so it's positive root 5. And then we put the same thing on the top. Let's see what happens if we do this. So on the top we have 6 times 3 plus root 5. We need a bracket for this, so 6 lots of 3 plus root 5. And on the bottom, we need to put brackets around both of these. So we've got 3 minus root 5 multiplied by 3 plus root 5. Let's start by expanding the top. We do 6 times 3, which gives you 18. And then 6 times root 5, which is 6 root 5. On the bottom, we need to expand a double bracket. Let's start with 3 times 3, which gives you 9. And then move on to 3 times root 5, which is 3 root 5. And do negative root 5 times 3, that's negative 3 root 5. And negative root 5 times positive root 5, which is a negative 5. Now on the top there's no simplifying we can do, so let's just write that the same, but on the bottom we can. We have 9 take away 5, which gives you 4, and then we also have these surds, 3 root 5 subtract 3 root 5, which gives you 0. So you can see the surds cancel out, and the denominator is just 4. And 4 is a rational number, so we've now rationalized the denominator. The reason this happened was because of our careful choice of what we multiplied by. If you multiply by the same denominator here but switch the sign, the surds are always going to cancel out. For this question, there's a little bit of simplifying we can do as well. If you see here we have 18 over 4, well they're both even numbers, and we also have the term 6 root 5, and 6 is an even number. So we have 3 terms here, we have 18, 6 root 5, and 4. They all have a common factor of 2, so we can half them. Half of 18 is 9. Half of 6 root 5 is 3 root 5. Notice we don't divide the root 5 by 2, just the 6. And then 4 divided by 2 is 2. Now let's try a really tricky example. So for this one here, we've actually got 2 terms on the top and the bottom, and the surds there can be simplified themselves first. So let's start with root 54. This is the same as root 9 times root 6, and root 9 is just 3, so that's 3 times root 6, or 3 root 6. And then the root 24 can also be simplified. That's root 4 times root 6. Root 4 is just 2, so we have 2 times root 6, which is 2 root 6. So let's replace root 54 with 3 root 6, and root 24 with 2 root 6. So now we're ready to attempt to rationalize the denominator. Since this one has 2 terms on the bottom, we're going to multiply it by exactly the same thing again, but we're going to change the sign in between them. So instead of 2 root 6 subtract 3, we're going to do 2 root 6 plus 3. And that's the same on the bottom as well. Now we can begin multiplying these. We're going to need brackets for all of them. So we've got inner bracket 3 root 6 minus 7 times inner bracket 2 root 6 plus 3. And on the bottom, inner bracket 2 root 6 minus 3 and also 2 root 6 plus 3. So we've got lots of expanding to do here. Let's start with the top. 3 root 6 times 2 root 6. To do this, we could multiply the root 6's together, which gives you 6. And then also multiply 3 and 2, which also gives you 6. So it's 6 times 6, which is 36. Then we move on to this one here. We've got 3 root 6 times positive 3. That's 9 root 6. Then we move on to negative 7 times 2 root 6. That's negative 14 root 6. And negative 7 times a positive 3. That's negative 21. Now let's expand the one on the bottom. So we've got 2 root 6 multiplied by itself. We do root 6 times root 6, which is 6. And then we've also got 2 times 2, which is 4. So we've got 6 times 4, which is 24. Then we have 2 root 6 times by a positive 3. That's going to be positive 6 root 6. And then we have negative 3 times 2 root 6. That's negative 6 root 6. And then negative 3 multiplied by a positive 3. That gives you negative 9. So there's quite a bit of simplifying we can do here. On the top we have 36 minus 21. Which is going to give you 15. And we've also got 9 root 6 take away 14 root 6. If you do 9 take away 14, you end up with negative 5, so it's negative 5 root 6. On the bottom, we have 24 subtract 9. That's going to give you 15 as well. And we've also got 6 root 6 subtract 6 root 6. And these two terms cancel out to give 0. So on the bottom it's just 15, which is nice because that's a rational number. Much like the other one, we can also simplify this one. So the 15, the 5 and the 15 are all in the 5 times table. So if we do 15 divided by 5, we get 3. Negative 5 root 6 divided by 5 is just negative 1 root 6. And then 15 divided by 5 is also 3. So the fully simplified answer to this one is 3 subtract root 6 over 3.